All right, so I think this is recording. Let's take a look at three problems here in this video. Um, we take a look at these equations, and these equations are referred to as rational equations. We see that we have variables in the denominator. And whenever you have variables in the denominator, you need to be concerned and a little bit afraid of division by zero. So when we get our solution, it's only a possible solution because we have to check it against the original equation to see if it's whether it's extraneous or not, whether our technique in solving this gave us a solution that doesn't make the original equation valid. Let's take a look here at number 4. And I notice in the denominator here, 3x minus 12, that I can factor that. So before I jump in and try and find a common denominator of these three terms, I want to factor my denominators. So 3x minus 12, both of these have a common factor of 3. And this can be written as 3 times the quantity x minus 4. And now I can see that this x minus 4 in the second term is missing a factor of 3. So I can just right now jump in and say, well, if I multiply that by 3 over 3, then I'll have the same denominator in these two terms. And if I look at this 2/3, I can multiply this by the number 1 and write it as x minus 4 divided by x minus 4. And let's look and see what I have. So in the first term over here, I have 7 over 3 times x minus 4 minus, well, 1 times 3 is just 3. And when you're multiplying fractions together, just multiply the numerators and denominators together. X minus 4 times 3, the order of multiplication, it's commutative. You can change the order of multiplication. So x minus 4 times 3 is the same thing as 3 times x minus 4. Over here, I've got 2 times this quantity x minus 4. I can distribute that in just a second. And then here, 3 times x minus 4. So I can see now that I have the same denominator in all three terms. I can also see that I want to make sure that 4 is not in the solution set, that 4 minus 4 would cause division by 0. So now that I have a common denominator to all terms, if I were to multiply this equation by that common denominator, all I'd have left is the numerators. So I'd have 7 minus 3 is equal to, I'm going to go ahead and distribute this now, 2x minus 8. So 7 minus 3 is 4, but let's add 8 to both sides, and 4 plus 8 is 12. And it's obvious that 2 times 6 is 12, that our solution x equals 6. And that's not one of the, that's not going to give me an extraneous solution. 6 minus 4 is not 0. I don't have to be concerned about this solution. If it's a wrong solution, it's because I've done some silly arithmetic error. The technique itself of getting a common denominator is a valid technique. All right, so let's shrink this up so I can do these other problems. I have a tendency that I write kind of big. And I'm getting a little bit better with this software. All right. So let's take a look at number 5 here. And again, before I jump in and find a common denominator, I can see on the right-hand side this x squared minus x that I want to factor that denominator. So on the left-hand side, I have 2 over x, adding 6 over x minus 1. And on the right-hand side, I have 6 over, and x is common to both of those terms. So we can rewrite this denominator as x times the quantity x minus 1. So there's going to be the denominator that we want for every term. So this first term, 2 over x, we multiply it by the number 1, but we write 1 as x minus 1 divided by x minus 1. And this second term, we want its denominator to be x times the quantity x minus 1, so we multiply it by the number 1, but we're clever in how we write the number 1, and we write it as x over x. The right-hand side, I'm not going to do anything to it. It has the denominator that I want. And I can make my statement now that, boy, x had better not be 0, because that's going to cause division by 0. You're going to have 2 divided by 0, and that's undefined. And in my solution set, x had better not be 1, because if x were allowed to be 1, you wouldn't have a number equal to a number. On the left-hand side, 1 minus 1, that's 6 divided by 0, and that's undefined. So the left-hand side isn't even a number, and how could that equal, well, 1 minus 1, undefined doesn't equal undefined. It has to be a number equal to a number. All right, so now that we have a common denominator, we can focus our attention on the numerator, because if we were to multiply every term in this equation by that common denominator, all these denominators would cancel. So I have 2 times the quantity x minus 1. Let's distribute that now. So I have 2 times x, and then the second term, it gets multiplied by 2. Then I have addition right here, and 6 times x. And on the right-hand side, just 6. So this is this is reduced and is a considerably easier equation to solve than the original equation. We've got like terms. 2x plus 6x is 8x. And if we add 2 to each side, 6 plus 2 is 8. And if we divide each side by 8, we have a possible solution of 1. But wait a minute, here's a situation where this is extraneous. We've already said that, hey, x can't be 1. So if this is our only possibility and it's extraneous, it does not satisfy the original equation. The original equation has no solution. That was the only candidate. All right. See if I can shrink this up to work on number 6 over there. Yeah. Oh, this software is neat. All right. I'm going to change colors. So I see that I have a common denominator already on the left-hand side, but remember that comment that I made, I think, in another video, that, hey, you can't ignore that 3. That 3 has a denominator of 1, and that 1 is not an x. So if I have 2 over x plus 1 over x, then on the left-hand side, whenever you have a common denominator, you can just do that operation. I've got 2 plus 1, which is 3. Now, on the right-hand side, 3 over 1. See, this doesn't have the same denominator. So I'm going to multiply this by x over x. And now, what do I have? Well, both of these terms have a denominator of x. On the left-hand side, I have 2 plus 1. Hey, that's 3. And over here, 3 times x, because if I multiply by the denominator there, the denominator is clear. Now, again, I've got to really try to train myself to make the remark that I can't divide by 0, that when I find my solution, I have to make sure it's not 0, because 2 divided by 0 is undefined. But here, if we divide both sides by 3, it's easy to see that 3 times 1 is 3, that x equals 1 is our solution. So we had a no solution for our middle problem because the only possible solution was extraneous. The number 4 had a solution of x equals 6. Number 5, no solution. Number 6, x equals 1. Hope that helps. I will talk to you later. Bye.